Hello everyone. As we know that in the current in-vehicle network standard, now we have combination of multiple in-vehicle network standard like you have CAN, CAN-FT, FlexRay along with the automotive Ethernet. And the way they work is that there is a gateway which translates the CAN, CAN-FT traffic into automotive Ethernet, and so always there is the messaging has to go through gateway for the translation part. So in this example, what we are trying to showcase is that how do you perform some of the timing measurements or a latency measurement where we are translating the CAN network into automotive Ethernet, because latency is very important for some of the mission critical applications like the autonomous driving. So users wants to know that how much time it took from the data from sensor to reach to the microprocessor and ultimately to the actuator. So in this case we are simulating a scenario like that using Intrepid CS Red Galaxy box. I'm showing the user interface of the vehicle spice software where we are simulating a CAN network. So in this case we have different sensors connected like a speed sensor, temperature sensor, and which are translated into automotive Ethernet. In this case we are trying to demonstrate that when you send a data from CAN FT network and how much time it takes to reach the automotive Ethernet. So in this case we are using CAN to Ethernet packet translation. So as you can see, we have programmed CAN interface to send a bit stream of 69, and which we are converting into TCP and sending over the Ethernet fan. So once you send this packet, you click on the transmit button. This message is sent through automotive Ethernet, which is a translation of CAN to automotive Ethernet interface. So we have programmed this in a mini core, and now if you see the connection here, we are probing on the CAN bus to trigger on the CAN bus because we are interested in measuring the latency time from CAN to automotive Ethernet. And then we are using probing on the automotive Ethernet as well. So we are using a signal separation technique to do a protocol decode. So this is a method which is a non-intrusive method of doing a protocol decode, and very helpful for doing a precise timing measurement. So as you can see here, we are triggering on the CAN bus, and it gives you the time also, how much time it took to translate the CAN into automotive Ethernet. It is 179 microseconds. So if I again clear and do a single run, which is again a trigger on the CAN bus, you can see the value is 70. So this is how you can do a precise timing measurement using between the CAN FT standard to automotive Ethernet. Similarly, you can use this approach to do MII to automotive Ethernet latency measurement. So any precise timing measurement if you want to perform for automotive Ethernet, that you can perform using this technique. So in this case, on the CAN we have sent 70, and the same data we see in the TCP data as well, which is 70. Any precise timing measurements, you can use this method. If you're using a directional coupler based approach, directional coupler has its own propagation delay, so you may not be able to perform a precise timing measurement. But in this approach, it's we are just sniffing the data and doing the signal separation in the software, and we are able to perform accurate timing measurement using this technique. If you want to see a demo of this, feel free to contact our team. Thank you.